Morning, everybody. Whoa. What are you doing? Huh? This is some flashback from last quarter?
Yeah, I felt it fast enough,
All right. Ryan. Yeah. All right. So Ryan, it's different this quarter. I'm talking into this camera here for just a second. And I'm yellow, but I don't understand why. Doesn't matter. Good morning, everybody. Assuming we are functional, the local time is 9:50 a.m. on a Friday morning. Welcome to Ellensburg, Washington, USA. We will begin our program at the top of the hour on Ice Age floods. Ryan's having his breakfast. It's Old Home Week. Ryan and Bryce are sitting in. They had a good time last quarter and they missed this experience because none of their classes are face-to-face. I'm putting words in your mouth now, but that's what Bryce told me. Yeah, okay. So they're in their usual spots from last quarter, and I'm glad that you're with us. So if you're watching this in replay form, go ahead and skip ahead 10 minutes. We will begin talking, and here's the outline for the day. I'll give you a chance to look at it. Find my coffee mug. Devontae, you done? Okay. Where did I put my coffee mug? I didn't mean to rush you. Okay. All right. Thank you. You bet. Are we functional? Good morning. Where are you viewing from? The South Shore of Lake Erie. That's John. Jason wants to know, how do I get the chat off of my screen? I'll let you guys figure that out. Germany, good morning. Saber's already upset we're not talking about Glacial Lake Columbia. It is 5x5, that's good. I do have the correct camera. You are widescreen. I have turned off the auto white balance, but I've kept the auto focus. I thought I kept the auto focus. Mason, can't handle it. Thank you. Too much going on in my head. Uh-oh, okay. I'm turning off auto. Oh, no, it's off. I don't get why some mornings I'm yellow, but I guess the experiment today is I've taken the spotlights away. We're not using them out behind you. So I think there's enough light for you, home viewer. I think there's enough light for these guys to copy things down. Emily from Bickleton's here. What was your name?
Me?
Yeah.
Emily also.
Okay. Okay, I knew there were Emily. Okay. Emily, so that Emily from Bickleton, and this is Emily from Cleellum, right here in the county. And there's Eve, another E woman. We have 3 E women in here. Thank you. So the 2 Emilys are my new names for today. Okay, more from you guys and just saying good morning. And we have a Friday morning crowd. You know, back in the before times, Friday mornings were always really fun because Monday through Thursday, again, before the virus, Monday through Thursday, there's a class right before, there's a class right after. I got to get out of the room real quick. There's hallways full of people. It's just, you know, loud and everything else. That's Monday through Thursday. But then Friday was always, nobody had class. Whatever, that's a whole nother thing that's developed recently. So I love teaching on Friday morning because I could visit with people before class and stick around afterwards because it was just us. Well, every day's Friday now. Every day's Friday. There's nobody in the frickin' building except if I see somebody in the hallway, I know they're in my class because there's nobody else walking around in the building. So, it's too quiet in here. Would you mind introducing yourself to people sitting around you? Honestly, I know it's Friday and it's morning. And please, right now. I'll come and introduce myself too. So you guys still living together?
Yeah, basically.
How many times have you had the virus?
0.
15?
15. Yeah, you're looking good. It's kind of pale. So that
Yeah.
14th time really got you.
Uh-huh.
Yeah, you're back though. Okay. All right. What's the scene? You're both in Wendell Hill.
Yeah.
Uh,
It's still a party dorm, but it's not as
Party
crazy.
floor. I don't live on the party.
Oh, okay.
It's like
All right.
there's not a lot of parties in the building anymore.
Okay.
There's people going out, so but nothing. We're still waiting our results from when we got back.
Yeah.
Because for some reason they sent us 2 those things, it's taking longer and longer.
Right.
So
I think it's 2 weeks now since we took that test.
yeah.
Is everybody following the rules more or less as far as taking the test?
It's hard to say because we don't know if anyone is testing positive or not. So
Like I got an email from the provost saying I don't know how serious they are, but they're going to try to like yank people out of classes if they haven't tested. I have no idea how they would,
Yeah.
how serious they are, but
yeah, I
I
don't
just
know.
think
if it's a big problem and people aren't doing it, you guys did it, you tested.
Yeah, but all of our
Multiple
classes are
times.
online, so it didn't really matter.
Oh, but you're on campus. Yeah. Yeah. All right. All right. We got people chit chatting now. That's good. A few more hellos for you guys. Hello from Portugal. Well, hello from the United States of America. Florida, same as Portugal, as far as I think. Brian, age 69, from Southampton, UK. Hello, Brian. New Zealand, hello, Rob. Red Deer, Alberta. Merrill, Wisconsin. Go Packers. Dawn is in Keighley, UK. Stephen's from the Grand Coulee. What? I'm glad that we're functional. I'm glad that I picked the right camera again. I guess the yellow, so maybe the yellow, some mornings it looks real yellow to me and other mornings it doesn't. I'll keep playing with it, but I guess it's, I don't know. I don't know. He doesn't know. Tim, good morning. Guy sitting behind Tim, what's your name? Spell it for me, please. Kade. Where'd you grow up, Cade? Yakima. Wonderful. Do you know Tim? You guys grew up within 30 miles of each other. This episode of Nick from Home brought to you by brown nosing Mason's gift to me this morning, which I appreciate.
I'm thankful not only to someone who do this, but also for you specifically that to
Well, I heard you.
We passed the big hunks chocolate bar.
Oh, no. No.
Nick, I'm not just talking about the
Da. Mm-hmm. David's in California. He's 70 years old. Oh, there's. Can you hear the chit chatter now? I don't want to call it out because it's so nice to hear. Well, the old dudes are helping out. Oh, now they hear me say that. Now it all went quiet. Adrian is 72 years old. Now we have people checking with their ages. This is interesting. Moto Mining has got to go grab a drink. Good to know. Going to the bathroom. Going into the kitchen to grab a cracker. We have 1 minute. Thank you for joining us. Cade. Tim, Mason, Emily Bickleton, Emily Hanson, it wasn't King, it was Emily something. I'm on my mic. Your last name is not that. I don't know why you made me say that. That's not your last name.
No, also, like, this is an expert.
Well, good morning, everybody. It's wonderful to see you all. We have a full room. We have energy on a Friday morning. That is wonderful. If the telephones could go away, please. I have information for you. Today and Monday is a two-part lecture, two-day lecture on the Ice Age floods, sometimes called the Missoula floods, sometimes called the Spokane floods, sometimes called the Brett's floods. And you're like, I don't care. I haven't even heard of any of those. That's great. That's why you're here. You're taking Geology 101. Most of you grew up in this state, but you do not know about this topic, and I'm very excited to share it with you. The outline today is not really an outline. I'm going to be especially loosey-goosey today. So I'm trying to stay out of your way so that you can copy that down. You know by now that that's encouraged. Each time you come in and sit down, you chit-chat a little bit, but you also get this outline down because you know it's not going to be around forever. But today it's not really an outline. It's just a kind of a laundry list of things that I'm going to weave together. I'm going to tell you a big old story using a brand new chalkboard this morning that has state outlines on it. And I want to give you that story of the Ice Age floods in story form, and I'll weave in most of these concepts. And I suppose when I'm done with the story, I'll say, did I hit everything on our outline, even though it's not really an outline? You know what I mean now? And before we quit, I'll make sure that you have some visuals and a couple of animations and a couple of kind of 3D things, not 3D, but colorful things to make this work. And I have confidence that you'll have questions, that you'll want to know more, because this story tells itself. This is one of the most exciting geological stories anywhere, and we have it right here in Eastern Washington. I'd love to get started right now. However, I want to tell you about the midterm on Tuesday. There. I'm going to hold this. You can jot this down if you like, but this is what I want to tell you about our midterm exam. And you're like, wait a minute, this is like my third time ever in this classroom and you're giving me a midterm? You're damn right I am. After today, we'll have Monday's lecture, which will be a lecture number 11. It's time for a midterm. And if you have missed any of our lectures, whether they're in person or online, they're all available on my YouTube channel. Please watch them. And who remembers the one additional thing I wanted you to watch? What was the topic? Thank you, the Milankovitch cycle. Type into YouTube search box, Milankovitch cycle, Nick Zentner, and you'll find a backyard session I had on Milankovitch. I'm expecting you to know that stuff as well. Okay? So here's the detail of what is to be expected on Tuesday, and I'm not going to talk about it on Monday. So this is your time to hear about it. It's a 70-point exam. It's a full hour-long exam. Townies, we're not meeting with you. I'm not turning the camera on. Tuesday is only a midterm exam for these guys. Monday, yes. Tuesday, no. So it's going to be a full hour midterm. It's going to cover everything from day one up through Monday's lecture. It will cover a bunch of stuff that many of you prepared for the quiz yesterday and was not on the quiz. That was not wasted effort. That will show up on the midterm on Tuesday. Okay? So it's everything from day one up through Monday's material. And it's a full hour lecture. Now notice it's a 70-point exam, but I have 15 multiple choice questions for you. The first 2.5 pages, each multiple choice question, 2 points each. 15 times 2 is 30 last time I checked. Similar in style and depth to the quiz I gave you yesterday. And there will be 5 essay questions, but I need to explain that. So there'll be 5 8-point questions on Tuesday. But each of the 5 questions will be different style. One of the essay questions is truly an essay question. And I already told you what it's going to be about. It's about the oxygen isotopes on the deep ocean sediment. So make sure you're ready for that. Another 8-point question is going to be a math problem. You can probably figure out what that is as well. That's the absolute age stuff. So right there, that's 16 points. I'm telling you, the two 8-point questions right now. The remaining essay questions, one is a big diagram that I give you and you do something with it. A couple of the others are kind of short answer kind of deals. Okay, so there's a variety of things on the quiz. Who's got questions about midterm 1? It's a big day for us. Admittedly, this is a strange quarter. We all know this is a weird thing we're all going through. I'll be a little bit more forgiving, I think, with my grading than I normally am because of this oddness about not seeing each other face to face during the whole quarter. But I am serious about evaluating you, and then there's no more excuses after that. We're meeting each day in person. Anybody? It's lecture-based. It's notes-based. There's no extra stuff to study. I encourage you to visit, to work a study group, to do some stuff in person, buy somebody a cup of coffee down at the Starbucks and study together, whatever you like. But we need you to be prepared. You don't want to dig out of a huge hole. And if that quiz yesterday went very poorly, that's a wake up, that's a slap in your face right there. Please spend more time with this class. I have graded all your quizzes. I've posted your quiz scores on Canvas. Did you see that? If you didn't, it's there. And one time only, I'll have the answer key to the quiz. I have it right now. I'm pointing to my office. So halfway down the hall on the left, if you leave this building this morning, if you want to see the answers, I'm not going to turn your quiz back to you. I'll just let you look at the answer key if you're confused on what the score was that you got on your quiz. Okay? That's enough. Let's get started. Hey, last chance. Anybody? Okay. So I'll give you another 2 seconds to get the rest of this down, and then our story begins. There are other places in the world that have experienced ice age floods. And ice age, you know what that means. That's the last 2.6 million years worth of time. That's the Pleistocene. And we've been talking about the ice age the last couple of days with glaciers and ice sheets and that sort of thing. But these are floods. And this brings in a whole new group of people that have intense interest in this topic. Even non-scientific people, if you know what I'm saying, are very interested in talking about a flood, a singular flood. So by far, this is one of the most, outside of earthquake and volcano discussions where there's danger and everybody's all whipped up into a frenzy for good reason. This topic is also a very, very popular one worldwide. But there's only a couple of places, just a handful of places that have experienced massive ice age floods of water during the ice age, and the Pacific Northwest is one of them. That's one of the reasons I'm here to go. Okay, the energy is excellent for a Friday morning. And just to give myself a little extra boost, I wasn't expecting a albino Snickers, but what? Okay, let's go to the brand new. That was a mistake. It's a big moment. How's your geography? U.S. states. And can you see these little gold dots? These are cities. So just to get you acclimated in case you're totally lost right now, yeah, the TV screens might work better than seeing me up here. Seattle, Washington, Spokane, Lewiston, Idaho, Missoula, Montana, Boise, Idaho, Portland, Oregon, Pacific Ocean, British Columbia, not on the map. We're US-centric today. Okay? This is an ice age flood story that involves the entire Pacific Northwest. It's not just Washington. It's not just Eastern Washington. The entire Pacific Northwest were affected by these ice age floods. What's the first thing on your outline? There's some numbers. Thank you. Once upon a time, between 18,000 and 13,000 years ago. So keep one eye on that outline, quote unquote. Okay, you've got the spelling and you've got the words written down. This is a story that happens between 18,000 and 13,000 years ago. The first thing I want to do is put in the ice sheet. And we've talked about that ice sheet coming down from Canada. We've talked about that ice sheet over Seattle. I should probably bring it a little further south, right? The terminal moraine is down there by Tenino, south of Olympia. This is the Puget Lobe. So this is on your outline, lobe like an earlobe. So the ice sheet has places where it hangs down a little farther than other parts of the ice sheet. So it's going to go quickly because you've got the words in your outline. This is the Puget Lobe, ice sheet in western Washington. This is the Okanagan Lobe. You have it in the outline, Okanagan. And this is the Purcell Lobe. Each of these lobes will play a part in the story. No, that's wrong. We're done talking about the Puget Lobe. That's not part of our story. We're done talking about western Washington for a while. But it's the Okanagan and the Purcell lobes that are a big deal to us today and Monday. Fine. The Purcell lobe is where we start. Now notice the Purcell lobe is in northern Idaho, and it's a part of the ice sheet that is thousands of feet thick. But have you been to this area? It's mountainous. These are the Rocky Mountains here. And so we have valleys in western Montana, river valleys, that still exist today. I mean, this is only 18,000 to 13,000 years ago. This is not long ago. This is not even 1 million years ago. So this is yesterday geologically. But these valleys in western Montana started to fill with water because this Purcell lobe was acting like a dam, like Hoover Dam, sealing off a river valley and having a bunch of water, still water, back up behind it. That's what this is. So we will be talking a lot about the ice dam, quote unquote, the ice dam. This is it. The Purcell lobe is the ice dam. So, in a different colored chalk, we have a glacial lake, GLM, on your outline, Glacial Lake, Missoula. So I'll show you a bunch of maps and images and even a video clip, I can't remember, of the evidence that Glacial Lake, Missoula was a thing. But that's our first major point. We're going to have a flood of water, and we need a source of the water to have a big flood. And the source of the water, one major source of the water, is this Glacial Lake, Missoula. And why does it exist? Because the Purcell lobe crept over the border. The Purcell lobe blocked the outlet of many of these rivers in western Montana. It was a dam made out of ice, and there was water that was sitting in all these valleys up to a certain elevation when that Purcell lobe is there. With me so far? I don't expect back and forth until I get most of this story out to you, but then I'm definitely coming to you a little bit later today. Ready? We're going to do a flood. Actually, I'm going to come to you. What's going to happen? How are we going to get a flood of water, which is going to be a catastrophic burst of water? Correct. What's your name again? Michaela. Okay, I'm full today. I got 2 Emilys, and I got Michaela, Pedro, and Caden with a C. Shit. All right. Michaela is correct. We're going to get enough water ponded in Glacial Lake, Missoula to finally break or burst or breach the ice dam. Now, this is a key part of the story, obviously, but still a bit of a question mark. Like, what exactly happened? How did the ice dam fail? There's people watching from around the world right now, more than 900 of them. Some of them are big fans of Randall Carlson, who has a YouTube channel and books out. And he peddles the idea that it's impossible to have an ice dam and hold back a glacial Lake Missoula. The evidence is overwhelming that this is a thing. But like all stories, there are parts of the story that need a little bit more work, if possible. But this is a conventional story and a major story. If you look at the field evidence that exists in this area, there's no question that Glacial Lake Missoula was a thing and that this ice dam was a thing. Okay, so Michaela wants to make a flood by breaking the dam, and that's what we're going to do. So you want a timeline on this? We still don't have exact timeline, but let's roughly think of, I don't know, 50 to 100 years of slowly filling this basin to make Glacial Lake Missoula. We don't know exactly, but that's kind of the time we're talking about. Get the ice dam in place, 50 to 100 years of slow filling of this reservoir. That's really what it is, Glacial Lake Missoula. And then one Tuesday afternoon, we're going to burst the thing. So on the map, I just want to do that, just to cartoonishly show. That's an arrow. Do I need the rest of the dam still here? So I'm trying to show that we're going to release the water in Glacial Lake Missoula because we broke the ice dam. We tunneled underneath. We went over the top, a little bit of both. Nobody knows for sure. But based on the deposits we're about to talk about in eastern Washington and the erosion in eastern Washington we're about to talk about, we know that this happened quickly. How long did it take? Did we say to make this lake? 50 to 100 years. How long does it take to drain the lake? 48 hours. That's not a guess. This is knowing exactly how much water came through this area, how much fast water raced across eastern Washington. So this has been mathematically deduced from looking at all the evidence downstream and figuring out how much water came through this area and how fast the water was moving and therefore how much time it would take. Roughly 2 days, roughly 48 hours to empty Glacial Lake Missoula. Now we can argue about is it 48 hours or 63 hours? Doesn't matter. We just want a gradual time frame on this. Up to a century of building a lake, less than 2 days-ish to empty this lake. Now, where did the water go? Well, it went frickin' through eastern Washington, man. As he burps on his Snicker. What kind of white Snickers? What's wrong? Just give me the original next time, Mason. Just kidding. Thank you for the gift. Okay. Big arrows with a capital E associated with it. Anybody want to read my mind here? What are the arrows and what does the big E stand for, do you suppose? You want to try either one, Mason? Big arrows? Correct. So this is where we have the Ice Age floods. The actual floods are these big white arrows. We're going to look more carefully at it in just a second. Not all of eastern Washington was affected. But if you happen to be in a place where there is one of these arrows and the water is moving, I'm not exaggerating now, the water has been released from this lake and the water is now free to move at freeway speed. 40, 50, 60 miles an hour in places. This has been calculated. Again, hang on, Mason. Okay? So those places where this is white, where the white arrows are, is where we have high velocity flood water. You want to guess what the E is now? What is it?
Oh no, I was going to ask if these massive glacial floods in Glacial Lake Missoula flooding eastern Washington is why the land was so fertile.
We're getting there. We're getting there. Anybody want to guess on the E? We can think of yesterday. Thank you. Do you remember yesterday, late yesterday, we did something kind of important, although it was kind of rushed because I was running out of time. So I want to revisit yesterday real quick. I don't think you need to flip back necessarily. Yesterday, we had glacial erosion, do you remember? And glacial deposition. Actually, I do want to skip back. Using the yellow book or your memory, what are a couple of glacial, this is yesterday, ice, what are a couple of glacial landforms from erosion? Anybody? Yeah. In a ret. A couple more. Cirque. You on page what? 12. Thank you, Pedro. Yellow book, page 12. Those are all erosional, what? Thank you. Those are all erosional glacial landforms. I'm emphasizing this because page 12 are erosional landforms from ice. This is also erosion here, but this is not the ice that's doing the eroding. It's the water. The water is so voluminous, the water is so energetic, the water is moving so fast that this is almost unbelievable. We're going to carve valleys in a few days. I'm really slowing down now. This doesn't happen typically in geology. It used conventional thought, go to the Grand Canyon, it takes millions of years to carve the Grand Canyon. Hell, we were talking about the Yakima River Canyon. And the uplift began, if you recall, 3 million years ago, the Yakima River Canyon. And so a gradual uplift, intensifying erosion, that whole thing. This is different. And this is why 100 years ago, when a guy named J. Harlan Bretz was out here walking around, literally walking around, and hitchhiking on trains and making geologic maps, he came up with this evidence for this incredible Ice Age flood erosion that appeared to be water happening just in a couple of days or a week and cutting huge valleys. And of course, everybody in science said it was bullshit. Sorry, Patrick. Total bullshit. Sorry, Patrick. But we now see that the evidence does fit that story. So in a bit, with the visuals, we'll go visit these places where the white arrows are. We'll see why not? I'll give it to you now. You want it? The word coulee. On the outline, you have the word Grand Coulee, Coulee. We're going to the yellow book in a bit. A coulee is the main landform from Ice Age flood erosion. This is organization on your part. This is not hard stuff. But if you don't organize yourself properly, you're going to get page 12, which are glacial landforms from erosion, mixed up with coulees, which are erosion landforms, but from water, Ice Age flood water, not glacial, not ice. I want to finish the story, though. Are we feeling okay? Is this working for you? This is not a shameful place. This is not a place to get embarrassed. I'm just curious, and I do this every time I teach this. Raise your hand if you've never heard this story before. I'm not kidding now. Almost everybody. And you, K through 12, in a Washington school. My God. Okay, well, I'm glad you're getting it now. And I don't think it will really sink in as super exciting until you see some of the stuff I have to show you visually. Okay, I want to finish the story, however. So this stuff's going, let's say, more than 40 miles an hour. It's moving fast. Now, is it going to stay fast all the way to the ocean? It is not. By the way, sea level. This is a story happening between 18,000 and 13,000 years ago. So we're just starting to come off of the last glacial maximum. In other words, the ice is starting to melt back, but it's still pretty close to 18,000 years ago. Does anybody remember? Is sea level low or high during a glacial time? Is sea level high or low during a cold glacial time? It's low, right? Remember that whole thing? Interglacials, we raise the bathtub because all the water is being released into the oceans. And the opposite is true for a glacial. So this line I just drew here is the actual position of the West Coast 18,000 years ago. This was all land. And in the last 18,000 years, since we have been melting all the ice, that's a major point from a couple days ago, right? There's been a natural warming globally of ice sheets around the world. Sea level has been gradually rising so that sea level and our shoreline is here. But this is a submerged shoreline. So my point is, we're eventually, don't write these arrows down yet, please. But just to give you the concept, you're not writing it down yet because I'm going to do something different here. But in general, this ice age floodwater is going to get to the ocean. And it's a longer journey to the ocean then than it is now because we have raised the bathtub, what was it, 400 feet? I think that was the number. Okay. I asked you not to write this down. This is the pathway. What is this area? Bryce, what's this area called here? The Columbia River Gorge. I just jolted Bryce. Bryce lives in Carson, which is in the Columbia River Gorge. How many people, raise your hand again, please. I promise I won't embarrass you. How many people have been on the road that follows this Columbia River Gorge? Most of you. Okay, good. So this is the drive between Tri-Cities and Portland. You can drive the freeway on the Oregon side. You can drive State Route 14 on the Washington side. Go right by Bryce's house. And Bryce used to be so cute when he was in his backyard playing with his kickball. Glad you're here today, Bryce. Thank you for showing up. I erased this arrow because the floods, and you'll notice that it was multiple. It was plural, right? The title of this meeting is Floods. This happened more than once. It's hard enough to convince you it happened once probably, but we have overwhelming evidence that this happened dozens of times, not just once. We're just focusing on one of the floods. But my point is, the floods did not maintain their speed all the way to the ocean. In fact, the floods stopped. And made another lake. This is Glacial Lake Missoula. This is Lake Lewis, also on your outline. Not Glacial Lake Lewis. Technically, a glacial lake is a lake that forms when you have an ice dam holding the water back. We don't have an ice dam holding this water back to make Lake Lewis. Instead, we have WG. What does your outline say? Thank you, Mason. So let me explain Wallula Gap and its significance. WG is Wallula Gap. What is that? You got it written down in your outline. What is this here? Wallula Gap is the narrow entrance to the Columbia River Gorge. Most of you have done this drive, so you know that it's a steep-walled, narrow slot that goes right through the Cascades. These are the Cascade Mountains, right? A major north-south trending mountain range that we will talk a lot about in a couple of weeks. So there's really only one way for water to get from Montana to the Pacific Ocean, even today, and that is to go through this Columbia River Gorge, and Wallula Gap is the eastern entrance, the eastern narrow entrance, the gateway to the Columbia River Gorge. So all this Ice Age floodwater has to somehow squeeze through Wallula Gap. Are you starting to get the point? You can't keep all that. There's so much water in one flood, you can't just have it all thread through the Columbia River Gorge at once. There's no space. So why does Lake Lewis exist? It's water that is stopped and is waiting its turn to thread through, alliteration, no big deal, humble brag, to thread through the Wallula Gap and the Columbia River Gorge. This is a temporary holding pond for this Ice Age floodwater. So I put the capital letter E with the circle up here by the coulees. What capital letter am I going to put next to Lake Lewis? Correct. D for deposit. Again, reminding you of yesterday. Is this too much for you now? I'm going to have you go back to yesterday. What's a glacial landform from yesterday where ice deposited a landform? In other words, an ice deposited landform. An erratic or a moraine, either one. Thank you, Tim. Remember? Stuff dropped by the ice. That was yesterday, like a moraine or an erratic. Well, what am I saying here? I'm saying we have Ice Age flood, that's the water, depositing material. I'm losing some of you, I think. Why are we getting Ice Age flood deposits here on this part of the map? Somebody. We can do it. Somebody new. I'm going to push now a little bit. Yes?
Is it because the water kind of calms down there so that things sunk to the bottom?
You got it, Emily. Well done. The water calms down here. I would literally say the water stops. The water is standing in Glacial Lake Missoula. The water is released quickly through the breached ice dam. The water is moving up to 60 miles an hour, carving coulees, and the water is forced to stop again. If it stops again, it's going to drop material that it was picking up. It's a challenge for us to view water as more than water. In geology, we view rivers as more than water coming down the Yakima River. It's carrying a bunch of sediment. Same is true here. This fast-moving water is picking up sediment, and then it's going to deposit, Ice Age flood deposit, in the bottom of Lake Lewis. And then the water will eventually drain to the ocean. So you have slack water sediments. Again, this is housekeeping for you now. You have slack water sediment layers in your outline. That's the famous Ice Age flood deposits feature. I know you're saturated now, no pun intended. Har, har, har. I know it's too much now. It's just a bunch of words and an old guy up here talking with a piece of chalk, pretending he's smoking a cigarette. It's obnoxious, it's too much. So it's time, in just a second, to go to a bunch of images to bring this to life. Slackwater sediments are the main Ice Age flood deposits. And the slackwater sediments are being deposited at the bottom of Lake Lewis. They are the evidence for the floods, just like the coulees are evidence for the floods. And then this whole thing drains to the ocean. A couple quick questions from you, immediate questions, and then we'll switch to the laptop while we're doing that. Tim? Yes. Yeah, physics now, right?
People in, Idaho or Montana, roughly where that Purcell Lobes would have been, have they seen any evidence of it cutting under maybe a spot, like some kind of washout there?
Tim's asking about the details of the breach of the ice dam, and that's obviously a very interesting part of the story. And Tim's wondering, in Idaho, is there evidence for a breach? Is there evidence for a tunneling? Is there evidence for water going over the top? And there's evidence and high velocity water evidence, but it depends on who visits and what they see. So it's the evidence is there, but there's different interpretations on that. And it's one of those things we just may never know. I mean, the ice is gone. The water's gone. All we have are these gravels that are showing a sudden release of water. Okay, I was thinking maybe I could make this a little bit more user-friendly today. Well, that's not good. That's our live stream. We have almost 1,000 people watching. So yeah, this is going to work for both audiences the best that I can. And we'll tilt it so we don't have any reflection. Okay, that's my best attempt today to make this work. Okay, slideshow and animation time. You guys, are all the TVs working in the back? Okay, good. All right. So you can see the lobes here, I think, can't you? Mason, what?
Is this on the midterm on Tuesday, like this lecture on Mondays, or will that be on the next?
Everything from day one up through Monday will be on the midterm on Tuesday. Okay, so this is a little bit more accurate. We can see a little bit of water here, but let's get to the good stuff. I say, let's get to the good stuff. Oh, good Lord. Did I take that thing out? I did. Why did I take that out? Don't answer that. Thank you. I almost want to be over here. Like those home people can watch that. So this is called the channeled scab lens. It's not on your outline. You're not responsible for it, but can you see this is the place where we clearly have water coming through? And we have other ways to show those different lobes. Now I'm getting real picky. So, simplified map. You see Glacial Lake Missoula there? Frickin' three-ring circus up here. And again, the channeled scab lands where we're really just showing the individual channels. Please notice that there are places where the floods missed. Please notice there's all those white islands essentially. And that is super dramatic when you go out and visit. Super dramatic. I'm going to give you a word. It's also been on your outline, I think. Did I give you the word loess on the outline? I did. Good. So these white areas are called loess. L-O-E-S-S. There's stuff in the yellow book. Let's hold off on it for right now. I just want to still just kind of give you some visuals. This is Missoula, Montana. And do you see above the campus of University of Montana, there's a bunch of lines on the hillside? Those are the old lake shores of Glacial Lake Missoula. Those were noticed more than 100 years ago, and nobody knew how to interpret them. Now, we still don't know exactly how to interpret every shoreline. Is each of those lines a different lake? Tough to know. But we do know that the highest shoreline represents the deepest Glacial Lake Missoula. I really would appreciate you getting off the phones. I promise not to say that every time we meet, but I really would love it if you could just be totally locked in here. I'm in the room with you. You're here to learn geology. The phones are just a distraction. Bumble can wait. Okay. Beautiful picture from Montana. Used to be filled with Glacial Lake Missoula. Let's move on. Let's move on. Uh-oh. Uh-oh. Artist rendition. There's your ice dam breach. Tim, I don't think we can give you details, but we know that this drained quickly, and we know that this is erosion. What's the landform? What kind of landform forms here by the erosion? What landform is from Ice Age flood erosion? Coulee, thank you. And what can we find today where there's Lake Lewis not portrayed here? Slackwater sediments. We're getting there. This is a Tom Foster illustration showing a modern day image of Missoula and how deep the water was. Now remember, there were multiple floods, so there were multiple Glacial Lake Missoulas. That's too much for our brain right now, but that's also part of what we're talking about here. Tom Foster giving us a map, showing us exactly where the ice dam was. If you've ever been to Sand Point, Idaho, or Lake Coeur d'Alene, or Lake Pend d'Oreille, that's the country we're talking about that was underneath this ice dam. And then there's the release of the water. Let's do it. You ready? Cue the breaching. Oh, damn. Oh. Oh, damn. Oh, damn. Do that again. So this is just from like a program on TV. There's probably a copyright on it. I'll probably get in trouble putting it on YouTube. But they're giving us a scenario. Please notice two things. The ice dam fails, but it doesn't go away. It breaks into a bunch of ice cubes. And that will be a big part of Monday. Those are icebergs that are going to be floating in the water. So now we add visuals. It's not just water coming at us here in Eastern Washington. It's water that's carrying a bunch of these icebergs. I'll play it. Also notice that the water goes from blue to brown because we're stirring up the soil. And now this guy's going crazy. Look at this animator. He's going to swallow up the entire state of Washington, which is total bullshit, but he got carried away. He's in his little cubicle. Nobody kept him in check. Look at that thing. This is powerful enough that we don't need to have the entire state overrun by water, but you get the point. If you're in one of these channels, oh God, oh good Lord, this is not good. And that was the experience if you happen to be in the one of those pathways. And I have to say it, some of these Ice Age floods were less than 16,000 years ago, and we now have archaeological data to tell us that humans were in Eastern Washington at that time, Native Americans. So we don't have any direct evidence yet, but it's likely that there was human suffering from these Ice Age floods. That's how recent these events are. Washington Geological Survey giving us another version of the same story. Who's got questions? There must be questions now before we go to the yellow book. Come on now. Come on. Anything. I got an edge to me, but it's a good edge. It's not a bad edge. Mason?
Why do we see those loses form? I know.
That's coming. That's coming. Thank you. I'll put you off on, that's what we're doing in the yellow book, talking about the loess. Anybody else? About the water, about the glacial lake, about the ice dam? Nothing? Look, the water's getting all the way to the Pacific. The water is flooding down to Eugene, Oregon. Oh, let's do it. So, why can't you see this? I want you to be able to see the, oh shit. Sorry, Patrick. These guys at home, I'm going to narrate for you. The guys at home can see it. There's a running clock that's cropped off of your screen, but they can see it at home, I think. So this is all, but the numbers have been crunched. So first of all, this is not fantasy. This happened multiple times. And all of the erosional landforms like coulees and all the slackwater sediment layers, the deposits, have all been studied very carefully, and fluid hydraulics have been worked, and calculus and everything else to actually come up with this very realistic scenario. What am I showing you? I'm just going to show you an animation. The red star is Ellensburg. We never got a drop of water here, our valley. We missed the whole thing. But 30 miles to the east of here is Vantage. You wanted me to play it, don't you? I'll play it. Okay, I'm going to go back. So what you cannot see is the running clock, but I'm going to narrate for you the number of hours going by since the dam failed. And the colors are depth of water. So what's the red? Deep water. Where is that? Glacial Lake, Missoula, okay? And the blue is going to be shallow water. And then as you get from blue to green to yellow to red, you're getting deeper and deeper water. But the power of this is to show the speed of this. This is not over the course of 1,000,000 years. This is over the course of what? 48 freaking hours. Ready. Breach the dam. 2 hours after the dam breaks. 8 hours after the dam breaks. 10 hours after the dam breaks. 16 hours after the dam breaks. right now is 24 hours after the dam breaks. You can see the glacial Lake Missoula continues to empty, and more water forms Lake Lewis. Can you find Lake Lewis in this? Lake Lewis is getting orange right now. Can you see it? Let's go back and do it one more time. And please shout out questions if you have them. 10 hours. 20 hours. This is the whole Pacific Northwest we're looking at. This is not just Eastern Washington. 36 hours. You get it. Okay. Okay, I think it is time, I know it is time, to talk about Lus. And you don't need a close-up view of this because I also want to show you something in the yellow book. I got 5 minutes. Don't give up on me. Let's earn our weekend here, okay? Yellow book. Everybody got one now? They're all free. Anybody not have a yellow book? You guys going to leave those? Bryce right there? Okay, good. So let's go to page 13, please. This will be a nice concrete way to finish our session this morning, and it'll be a good launching point for us Monday. Still getting used to all this here. Okay. Page 13 shows what Eastern Washington looked like before the Ice Age floods. And you can also see, I think, my screen here, which is what the Lus looked like today. So what is Lus? Lus is kitchen flour. Lus is silt. You remember we talked about silt, which are those very fine particles that rivers deposit when the water is quiet. You talked about them on the quiz yesterday, silt. Silt particles are like the consistency of kitchen flour. But this Lus used to be a thick mantle of material across all of Eastern Washington before our Ice Age floods. From the Rocky Mountains to the crest of the Cascades, we have good evidence that there was a thick cover of Lus. Now, an obvious question is, where did the Lus come from? And all we can say is that the Lus was deposited by wind. Please write that down before we quit. We're about to quit. Hang with me. Lus is silt that was wind deposited. And you're like, okay, but where did the silt come from? Generally, if you ask me, I don't know if you are, but if you ask me, the kitchen flour, the silt, is coming from continental ice sheet areas where the glaciers grind up the rock, flush the silt out in front of the ice, and then the wind picks it up. But let's not worry about it. The point is, we had this amazing thick, and I mean like 200 feet thick deposit of Lus from the Cascades over to the Rockies. And that Lus, which is still just a bunch of kitchen flour, it's still just a bunch of, you can just sink your hands right into this stuff and pull this silt out. It's fragile. It's important to point this out because the Lus is going to get swept away easily if we bring one of our Ice Age floods into the area. So just a special note, and this is more for Monday, beneath the Lus is a bunch of bedrock. And the bedrock is a rock called basalt. We're going to talk about basalt lava rock on Monday, not now. But it's the Lus we're focusing on. Okay, so what happens if we do some erosion where the capital E is on our map? And the answer is, this is what we're going to finish with today. The next page is great evidence for Ice Age flooding. Quickly, what do we have? A coulee. What's a coulee? A coulee is a valley that has a very specific shape. And you can see it right here on page whatever it is. The valley has very steep walls. The valley has perfectly flat floors. And the valley does not have a frickin' river in it. coulees are box-shaped valleys with no rivers at the bottom. And for 100 years, geologists would visit these coulees and they're like, what in the F is going on? Why is this valley here? There's no river. We now realize that these coulees were carved quickly by these Ice Age floods. And it's as simple as going to a place that has a coulee that tells us where there was Ice Age flood water. And please note that these places that are in between the coulees are these fragile places where the loess is still there. So that's why this is exciting. You can go and visit Eastern Washington and see places like this beautiful picture that has nothing but loess in the frame. And here's a picture of that tan loess on top of the basalt lava rock. Again, no evidence of flooding yet. I got 1 minute. More of loess sitting on top of basalt. That's fine. That's fine. Oh. That's a real place in Eastern Washington. What is it? This is loess that was untouched. But why don't those fields continue across the whole picture? Because the Ice Age floods came through and swept most of that kitchen flour away. Same idea. And you can even fly, that's the last thing, you can even fly over those hills, and on this side of the picture, the floods took all the loess away. On this side of the picture, the loess is still there. It's that obvious and that consistent all across Eastern Washington, driving from here to Spokane in John Stockton's house. Thank you for your attention this morning. I appreciate you coming. Please keep your attendance up. That's obviously a huge part of what we're doing here. Enjoy your weekend. Part 2 of this scintillating lecture topic is on Monday. I love you. Goodbye. I'll visit with you momentarily. I'll see if there's any students to visit with first. Okay? Thank you. We'll do some live Q&A with you on this topic if you have them. We good? Good to see you guys. You're welcome to come anytime. Grab one of those if you want to schedule. Okay, nice.
I'm sad I missed you dragging your belt buckle.
Oh, you know, I didn't even think of that. I was running out of time. That was yesterday. And I'm like, I didn't do it.
Bummer.
And how am I going to do it? Like, you know, I have to do it in front of the camera now. Like,
You can have someone hold it. And then
Yeah.
just go with you.
You need an assistant to film you.
mm,
Get someone
Yeah.
actually filming so you can like move around.
well, I'm in love with myself, but even that's too much for me.
Really?
Yeah.
That's too much.
Right, that's right. Hi, Eve.
Can I take a picture of the chalkboard?
Absolutely, come on up. As long as you stay off the camera here, I'll bring it to you. Oh, this is a nice photo opportunity for the chalkboard here. This is great. You know what I should do? I should just keep that, shouldn't I? I'll just pick it up on Monday and just keep adding to it. Thank you. I was about to erase it, but that's perfect.
And then you said that the answers to the quiz are in your office?
There on the bulletin. Maybe I didn't speak clearly. A bulletin board outside of my office, just in the hallway. Yeah.
Thank
So
you.
you'll see it on the left. Yep. Mason.
Professor Nick, I think
Yeah.
you answered my question. So the sediment deposited by what's probably the glaciers grinding up everything
Yeah.
is incredibly fertile.
Right.
And that's where we see in the middle of the desert these massive green hills that are unaffected.
Yeah, I've learned since that the loess, it's not so much the mineral content in the loess that makes it fertile, it's more the consistency of it. And there's the pores, the open places between the kitchen flour particles are just perfect for holding water. So that's kind of the answer there. Yeah, very good. Pedro, you sticking around? The answer? Yeah, I guess I wasn't clear enough. I've got it in my bulletin board just right now, halfway down the hall on the left-hand side. If you find my office, room 134, you'll see the answers right there. Thanks.
I was always really confused about that because Washington has some of the most fertile soil in the
Yeah.
world, and we actually are one of China's #1 food exporters. We are directly responsible for feeding a huge part of their population.
Okay. Well, it's always been marketed as we have these rich volcanic soils, but that's the science of it is that's total baloney.
Well, and I figured who better to ask than a geologist.
Well, yeah, maybe we'll find a geologist one of these days to ask.
Yeah, maybe.
All right. Okay.
I'll do a real candy garments.
Oh, yeah. No more gifts. Now, come on. Now that's it. You did that act last time. I don't need any.
It's not like you're stealing grades or anything, so I don't have to feel bad about giving you
Look at my belly. I don't need Snickers bars, but thank you. Thank you.
Maybe look at your belly. Look at
All right. Okay. Thank you. You too. Bye-bye. Okay, everybody. We still have more than 900 of you here. The room is empty. Go ahead and type in some questions if you haven't yet, uppercase, and I'll try to answer a few here. How many Ice Age floods have there been? Difficult question to answer. Obviously a good question. You heard what I typically say in 101 land, dozens. Depends on how to interpret the slackwater sediments. And that's more of a question for Monday, but dozens is the safest way to answer it at this point. John, or GJON, why would Glacial Lake Missoula drain over the Continental Divide rather than draining down the Missouri River? Thank you. Everything's west of the divide. Oh, is that true? The whole story happens west of the Continental Divide. So I may be wrong. I know the Continental Divide is down the Garden Wall in Glacier National Park, which is here, and this is just, even the Glacial Lake Missoula is west of the divide. So you're right. It wouldn't make sense if it's crossing the divide, but it's not. Kurt, can List be categorized by mineral makeup? Maybe there is a way to do it that way. You maybe heard my answer or my discussion with Mason. I was always confused why List was so productive for agriculture. We have amazing fields of dryland wheat where there's no irrigation, and yet there's still amazing crop production on those List soils. And I now realize it's got nothing to do with the mineral composition of the List. Instead, the particles are just perfect, and the thickness of the List is so perfect that it stores water beautifully. If that soil, List soils, if it was a bunch of sand, the snow melt would just drain right through. And if it was clay, it would all just pond on top. So that silt particle size is like perfect for storing water. But I don't know about the mineral part of it. Like I did yesterday, I'm just kind of scrambling between live and not live. Wasn't the ice sheet higher than the divide? Interesting question, Joni. I guess I don't know. Never thought of it that way. I can't tell you off the top of my head the thickness of the Purcell ice lobe, the elevation of that and the elevation of the crest of the Continental Divide, but we have all this water draining west, so I'm confident that the Continental Divide discussion is not at the heart of the matter here. Long strike or something like that. Was the Purcell Lobe the main culprit in all the glacial lake formations? I'll answer it this way. We're back to Jerome Lessman. It feels like I'm in love with this guy. I keep talking about him, and I guess I am. Jerome up in British Columbia has been studying landforms up here in British Columbia And this is an amazing amount of ice that melted away. And Jerome and other Canadian geologists are like, where did all that water go? You're telling me that this incredibly thick ice sheet is right to the north of the channeled scablands and there's no water coming from here and going in here? You're saying that all the water is coming from Glacial Lake Missoula? And he makes an excellent point, and I've had multiple discussions with him. He's at Vancouver Island University, but there are other geologists up there as well who have been studying these deposits and these Pleistocene deposits in British Columbia. So for simplicity, I'll be focusing only on Glacial Lake Missoula with these students, but it seems quite obvious that there are water sources coming directly from British Columbia as well, but not as well established in the literature. There's just not that many people doing the research these days. Tennessee Nana or Nana, do Randy's people have any stories about the flood? They do. Randy Lewis is a Native American who lives in Wenatchee, and I have gotten to know him. It's kind of a weird relationship. We don't see each other for months, and then when we are together, it's this intense thing, and I'm learning all this amazing stuff from him, and he has all these oral traditions ready to go. And I did a live stream with him, and we were in a little film together. And he does have those stories, and the next time, I mean, we've been distant from each other. Wenatchee's not that far away, and we keep scheduling to go out together and me recording him again, but we keep running into problems with fires and heat and now the corona stuff. Anyway, there are stories, Native American stories. I don't know them, but I've heard enough from him just casually. I really want to record those, and so does he. We just have to get together. Scrolling back, where did the water come from? Impact? Okay, well, I'm going to try to be measured about this. I try my best in all the things that I do to feature the evidence and build the story around the evidence. Now, admittedly, in the 101 world here, today I started with the story and then kind of slowly got into the evidence, but a more detailed geologic group who has a little experience with geology, I'm always very careful to separate the field data from the interpretations. Now, when we get into impact stories, I am completely open to any and all possible interpretations. But I'm only really excited about them if those stories fit with the evidence that's been collected. And some of the stories that have a lot of juice and a lot of momentum and a lot of followers, to me, does not have anything to do with the available dates and deposits and calculations that we have from the decades of field mapping that's been done. So I think you're hearing what I'm saying. I can't rule out an impact origin to some flooding somewhere in the world. But to tie an impact and say that's for sure the story for here, that's baloney, because it doesn't match with this evidence. We have field evidence for dozens of floods. And I've got other programs online that go through all that evidence. If you want one, there's a lecture I did called Dating the Ice Age Floods, a downtown lecture. I was happy with that, except for the audio-visual recording of it. But that's as much detailed field data as I've been able to put out in one talk. I'd recommend seeing that. To have that work with an impact hypothesis, it doesn't work. If you're true to the field data, those other stories, they got nothing to do with that data. A few more. A common question from Greg. It's a good question. What kept the floodwaters from destroying Wallula Gap? Are you still able to see this? Yeah. So was hoping there's usually a bit more interaction. There's only 20 kids in here, so it's just a numbers thing. I think people are a little. I'll eventually, I think, get them to speak up a little bit more, but that's usually a question that comes. Like, why did Wallula Gap hold that water back? Why didn't the floodwaters, if it was moving so fast, just blast right through and make a much bigger hole? And the answer is a combination of things. First of all, this is the Pasco Basin, and it's broad and open. So the waters were cutting coulees, but the water was emerging from the coulees way back up here, and the water was already slowing down. It was filling this big, broad, open Pasco Basin. So the water was already slowing as it was filling a broad area, and then Wallula Gap is a shock to the water system. It is narrow, and it is a barrier. Now, that said, Wallula Gap was clearly enlarged and deepened. And even if you hike on both sides of Wallula Gap up high, you can see scour and erosion up above. But it did the job in general in holding much of the water back. It's an interesting part of the story. Still scrolling backwards. Another one about Wallula Gap. More about the impact. It just frustrates me when there's one interpretation peddled and everything else is incorrect. Because it's backwards. You're supposed to look at all the evidence. You're continually supposed to survey all the field evidence, all the dates, all the good evidence we have. You can't just grab a couple of the pieces of the body of evidence that we have and then tell your favorite story. How many ice age floods have, okay, so dozens. We're getting kind of the same questions as I'm just kind of rumbling around here. I'm going back to live now just for fun. Native American stories, dude. What did geezers tell you? Tell us. I don't know what to do with that question. Is there a specific pinch point forming Glacial Lake Condon? From Pat Miller in Yakima. Jim O'Connor is one of the leading geologists, and he's my age. He's still working on this stuff, and he's been mapping in the Columbia Gorge. And so on some ice age flood maps, you will see another one of these lakes called Glacial Lake Condon, right in here. And so, Pat, the answer is yes. There are places in the Columbia Gorge where it gets narrow. And each time you choke the gorge down, you make a little bit more of a constriction. They have like mini Wallula Gaps all the way through the Columbia Gorge. There's even a mini Wallula Gap downstream of Portland, which is causing a choke and therefore backing up water down to Eugene, Oregon. This is, again, more Monday when we're talking about deposits. But Jim O'Connor doesn't like the term Lake Condon or Glacial Lake Condon because he says this really wasn't a standing body of water hardly at all. This was, but by this time we've already got the water moving and it was just kind of a swollen, kind of much more temporary retention pond than even Lake Lewis was. But if you're asking specifically, I think near Mosier, I believe, there's kind of a narrow spot, or maybe just downstream of the Dalles. I kind of forget. Yeah. Papa Soup. About how long was Lake Lewis around to deposit sediment? Thank you. Again, I'll share it with you, but that's mostly Monday. A week or two. So 48 hours of draining, evidence that this lake, each time we had a Lake Lewis, it was just a week or two. And there's evidence for that. One of the lines of evidence is there are not obvious big shorelines for Lake Lewis like there are for Glacial Lake Missoula. And the thinking is the longer you have the lake, the more pronounced the notches are going to be cut into the hills above the lake or the old shorelines. There's other reasons as well, but you'll have to come Monday to get more of that. Couple more and we'll quit. Do I know of other places in the world where there were big ice age floods? Yeah, a couple come to mind, but I know hardly anything about them. Maybe somebody watching can correct me here. The Altai, it's in Russia or somewhere in Eastern Europe. One of the former Soviet areas. I think it's the Altai Gorge or Altai. Is that correct? I was just on a big conference with Vic Baker and a bunch of other flood. That's where I met Jerome Lessman about 5 years ago now, this May. And we did a multi-day trip through here, and I met this guy who was doing work. He kept talking about the Altai, or Alka. Somebody got it? Charlie, the Altai is where Russia meets China and Kazakhstan. Thank you. Altai in Siberia from Colin. Thank you. So yes, that's a place that has very similar fluid hydraulics, apparently. I can't say bigger or smaller or anything else. I don't think they have basalt. We'll talk about the role of basalt in forming some of these landforms. An English Channel, thank you, Peter. That's another place. So yeah, this isn't the only place, but I think it's safe to say the most carefully studied place worldwide to this point. Hello from Russia, Moscow State University. Hey, I can't remember the name of that scientist who was on that conference. He was fun to talk to. Was each flood smaller than the one before? Mr. Tony, thank you. You know, if you're looking, I think the answer is no. We have all sorts of evidence that the floods were of different sizes. Some were absolutely gargantuan-sized floods. Others were smaller. And maybe, Tony, you're coming from that question by looking at the shorelines and thinking that the lake must have been smaller and smaller. But if you want to go to the Huge Floods YouTube channel, hugefloods.com YouTube channel, or just type into YouTube Glacial Lake Missoula and then my name. That's the last video I made with Tom Foster. And I was shocked at how many basic questions remain. I mean, I emailed everybody, every Ice Age flood geologist who's alive. And I got emails from all of them. And I wrote that script based on all that. And they couldn't answer the most basic questions. They admitted it was like shocking that these basic questions remained. Each shoreline, is that a different glacial lake, or is it all one lake with varying levels? The slackwater sediments in northern Washington are the same slackwater sediments as in southern Washington, as down by Lewiston and Hell's Canyon with the Bonneville flood. All that stuff, there's miles to go with the research, but nobody's doing it. The funding isn't there, or the interest is, I don't know. Just hardly anybody's working on it. Rowena Gap is a pinch point in the gorge. Thank you. Okay, I think that's enough for this morning. I do thank you for joining us. I don't know, I guess I'll toast you when it comes to mind. So let's toast you. A toast to you. Here's to your health. Gesundheit. Here's to the health of your parents and your grandparents and your children and your grandchildren and your nieces and your nephews and your great aunt and your great uncle and your third cousins. Not your second, your third cousins. Here's to them. I hope you have a nice weekend. I'll be curious. Actually, I'll pause for just another minute to get some of your comments. What do you think? I didn't have the lights today. I didn't have the 3 major spotlights coming at me. Was the lighting just fine? Is there less reflection, light reflection in my glasses so that I can see you a little bit better possibly? Anything else with the technology part of it? Practice makes perfect, but I've actually gotten maybe 3 emails from people who say they can't hear. Like they can't hear. But that's on their end, right? You're hearing me just fine. When I watch the replay, the sound is fine as far as I'm concerned. So I'm just pausing here at the end just in case you wanted to add a little bit as we continue to kind of adjust this and adjust that. But I like that I can see the students even better. Those big 3 spotlights and the huge stands are gone. And I thought I needed those, but I don't know, this looks good enough to me. And maybe to you too. Okay. Have a good weekend. Thanks for tuning in. We'll see you Monday morning at 10 a.m. Pacific time for part 2 of our Ice Age floods discussion. I love you. Thank you, and goodbye. Oh, you want to see the empty classroom? Maybe at some point. Yes, I'm a tease.